Okay, in this video I'm going to show you how to do a system of inequalities when you have like interval notation like this. These are called intervals actually, it's not interval notation, and a second inequality here. Remember that a system of inequalities, or any kind of a system, is really two or more equations or inequalities that you need to graph somehow, okay? And you want to see where they either overlap or where they intersect at points. That would be the solution to the system itself. Now, let's take a quick look at this particular system and see if we can graph it. Now, when I see this, -2 is less than or equal to x, and x is less than or equal to 3, what I see here is what's called an interval. I can really break this up into two individual inequalities. I can see that -2 is less than or equal to x, if I just did that. Then I also see that x is less than or equal to 3, okay? Now I know that I can always flip this around, right? I can just make this really x is greater than or equal to -2, because keep the open side towards the x, right? And what I have here now are two inequalities. So I'm just going to go over here to my graph, and I'm going to graph that. So I go to x is -2, and I see it's right there. And remember, when you're on the xy axis, you want all the x's that are -2, and I'm going to have a solid line because I have an equal sign in there too. So I'm going to do that. And I want all the x's that are greater than or equal to -2. So I'm just going to put my arrows in that direction. Now I'm going to do the same thing with x is less than or equal to a +3. So I go 1, 2, 3. Here's where x is 3. But x is also 3 here, right? X is also 3 here, all the way up and down. I know, again, I have a vertical line, and again, it's a solid vertical line because I have an equal sign there. And I'm going to put my arrows in this direction. Basically what this interval says is that all the x's that I'm looking for have to be in here, because this is where the two lines overlap, the two graphs overlap. Okay, now I've got one more equation, or inequality rather, to look at here, and I see that x plus y is less than or equal to 5. Now I recognize this is in the standard form, right? Remember when the x and the y are on the same side? And the way I can use this real quickly is to use what's called the cover-up method, all right? And with the cover-up method, this is what I'll do. I'll just pretend that x is 0, so let me just put that down. If x is 0, cover it up, which means that my y has to be less than or equal to 5. So that would be 1 point on this new graph. 0 and 5, which would be right there. Now I'm going to do the same thing with the y. Let me just pretend y is 0. If y is 0, I see that x is less than or equal to 5, right? Which would be right here. X is 1, 2, 3, 4, 5, and y is 0. So there's that. Again, I have a less than or equal to sign. So what I'm going to do is connect these two dots with a solid line. There we go. And now I'm going to do what's called a test point. I want to see which side of this line I need to shade. Okay. So my test point, you can really just choose any point on either side of the graph. I tend to choose 0, 0, because then I can just plug it in here really easily and do mental math, right? If I just put x is 0 and I put y is 0, is 0 less than or equal to 5? And the answer is yes, which means that that 0, 0 should be covered up, right? Should be on the shaded side. So again, I do this. And now once I've done all those little arrows, I want to figure out where do all three
graphs overlap. And again, I see it looks like it's everything that I've done here in yellow. Okay. There we go. Now, what I just graphed, what I just colored in, is called the area of feasibility, which means that any point in that area should work in any single one of my inequalities. And again, let's just try, just choose a test point. I can see that 1, 1 is in there, right? So 1, 1 will be my test for this inequality. Let's just go ahead and see if it works. So let's put it into the first one. My x is 1. Is negative 2 less than or equal to 1? The answer is yes. Is 1 less than or equal to 3? Again, the answer is yes. Let's go to this inequality. Is 1 plus 1 less than or equal to 5? Again, the answer is yes. That means that this answer is probably a good answer, and my graph is probably correct. I hope that was helpful to you. All right, just remember, difficult problems are just a bunch of simple problems that you take apart and do individually, and they just stack right up. Okay, thanks a lot.